On September 22, 1979, an American military satellite saw the sky flash twice over a black, storm-covered stretch of ocean south of Africa. The signal looked like the signature of an atmospheric nuclear explosion. Inside the U.S. intelligence community, one assessment would later place the probability of a nuclear test above 90%. But the official scientific review reached a very different conclusion. No bomb, no secret test. Perhaps just sunlight reflecting from debris after a tiny object struck an aging satellite. One flash, two explanations, and somewhere between them, a truth dangerous enough to disturb the balance of the Cold War. This is the Vela Incident. At 0:53 Coordinated Universal Time, Vela 6911 was moving silently above Earth. It was one of a series of American satellites built to detect violations of the 1963 Limited Test Ban Treaty, which prohibited nuclear explosions in the atmosphere, underwater, and in space. Its most important instruments were called bang meters. They watched for a pattern that nuclear scientists knew well: an intense first burst of light, a brief dimming as the expanding shock wave obscured the fireball, then a longer second pulse as the fireball grew through the surrounding air. That double pulse was difficult to mistake. Before that night, Vela satellites had registered 41 atmospheric nuclear tests, all later confirmed by other evidence. Then, Vela 6911 detected another apparent double flash near the remote waters around the Prince Edward Islands. The satellite generated an alert known as Event 747. The location made the signal immediately disturbing. This was not an established Soviet or Chinese test site. It was a desolate region of violent seas, low clouds, and scattered islands under South African control. If the flash came from a weapon, someone had chosen one of the loneliest places on Earth to hide it. In Washington, the warning reached an administration already trapped between nuclear diplomacy and political survival. President Jimmy Carter had made non-proliferation central to his foreign policy. The United States had recently signed the SALT II agreement with the Soviet Union. Carter had also invested enormous political capital in the peace process between Egypt and Israel. Confirmation of an undeclared nuclear test could threaten all of it. His diary entry from that day did not record certainty. It recorded possibilities: South Africa, Israel operating from a ship, or nothing more than a natural phenomenon. But even the list revealed the danger. Two American partners were already surrounded by suspicion. South Africa was governed by apartheid and facing growing international isolation. It possessed uranium resources, a sophisticated defense industry, and an emerging nuclear weapons program. Israel maintained deliberate ambiguity about its own nuclear capability, refusing to confirm or deny that it possessed the bomb. The two governments had developed a secretive military relationship. Declassified records and later investigations indicate cooperation in defense technology and nuclear-related fields, but they do not publicly prove who, if anyone, was responsible for the flash. That distinction matters. The evidence points in several directions. The certainty does not. Within the U.S. government, analysts began searching for confirmation. Aircraft were sent to collect radioactive debris. Monitoring stations were examined for seismic signals. Weather patterns were reconstructed. Intelligence agencies studied whether fallout from the suspected location could have traveled toward Australia. Every instrument became a potential witness, and every silent instrument became an argument against the bomb. The initial optical signal was powerful evidence, but it was not enough by itself. No radioactive cloud was conclusively recovered by the American sampling flights. No unambiguous seismic signature settled the question. The flash had appeared in the field of view of only one aging satellite, and one of its systems used to help locate events was no longer operating. Then came the acoustic evidence. Far from the suspected site, hydrophones at Ascension Island had recorded signals traveling through the ocean. A naval research laboratory analysis later argued that the pattern was consistent with a near-surface explosion and could be traced toward the waters between Marion Island and Prince Edward Island. To investigators who already believed the flash was nuclear, the ocean seemed to have heard what the satellite had seen. But the acoustic case was disputed. The signal was indirect, the distance immense, and other government reviews said the corroborating evidence was insufficient. The hydrophones did not produce a photograph of a mushroom cloud. They produced pressure waves that still had to be interpreted. Another clue appeared thousands of miles away. Low levels of iodine-131 were reported in the thyroids of sheep in parts of southeastern Australia after the incident. Iodine-131 is associated with nuclear fission and has a short half-life, making it potentially significant. Researchers examined whether rain and wind could have carried fallout from the Southern Ocean toward Australian grazing land. Yet this clue also refused to become proof. Tests in New Zealand did not find the same evidence. The source of the Australian iodine was not conclusively tied to Event 747. Like the hydrophones, the sheep added weight to the nuclear interpretation without closing the case. By late 1979, parts of the American intelligence community were leaning hard toward a nuclear test. A CIA assessment described the probability as greater than 90%. Some defense officials also believed the weight of evidence pointed toward a detonation. But identifying the event was only the first question. Assigning responsibility was even harder. South Africa had the geography and an active weapons program. Israel had the technical capability many analysts suspected. Their covert relationship created a plausible path toward cooperation. Later investigators would argue that the flash marked an Israeli test conducted with South African assistance. Neither government admitted conducting one, and the public record still provides no uncontested weapon, ship, or launch site. For Carter, uncertainty may have been politically useful. If the United States formally determined that an allied country had conducted an illegal or prohibited nuclear test, American non-proliferation laws and foreign policy commitments could force sanctions, restrictions, or a diplomatic confrontation. Against South Africa, that could deepen an already explosive international crisis. Against Israel, it could shake the Middle East peace process and expose a nuclear reality successive governments had avoided confronting. But political convenience does not automatically prove a cover-up. It proves motive to prefer doubt. What happened next is where suspicion hardened. The White House Office of Science and Technology Policy assembled an independent panel of experts chaired by Jack Ruina, an MIT professor and former director of the Advanced Research Projects Agency. The panel included highly respected scientists and engineers. Its task was to determine whether the optical signal truly came from a nuclear explosion or whether some combination of natural events could explain it. From Ruina's chair, the problem was brutal. On one side sat a proven detection system and a signal resembling previous nuclear tests. On the other sat missing corroboration, conflicting measurements, and an aging satellite. Behind the science waited the White House, intelligence agencies, allied governments, and the architecture of nuclear diplomacy. The panel examined a crucial anomaly. Vela 6911 carried two optical detectors, and their measurements of the second pulse did not agree as closely as expected for light arriving directly from Earth. That discrepancy suggested the signal might have originated near the satellite itself. The panel also compared Event 747 with unexplained readings known informally as zoo events, signals that resembled nuclear flashes but could not be classified. Its final judgment, released in 1980, was cautious but devastating to the nuclear case. The panel could not rule out a detonation, yet concluded that the September 22nd signal probably did not come from one. A possible explanation involved a small meteoroid striking the satellite, producing debris that reflected sunlight into the sensors in an unusual sequence. It sounded improbable. A tiny collision, drifting debris, and sunlight had somehow imitated one of the most dangerous signals on Earth. But science asks which explanation best fits the available measurements. To the panel, the mismatch between the detectors mattered more than the frightening shape of the flash. Not everyone accepted that judgment. Critics argued that the panel had discounted the hydroacoustic analysis, lacked access to important intelligence, and treated the meteoroid explanation more generously than the nuclear one. A later declassified State Department account recorded a senior Defense Intelligence Agency official describing the investigation as a whitewash driven by political considerations. Scientists connected with the Vela program also maintained that the satellite had functioned correctly. The disagreement was no longer simply bomb versus meteor. It became intelligence versus scientific review, and beneath both, the question of whether policy had shaped the standard of proof. Years passed. South Africa eventually acknowledged that it had secretly built 6 completed nuclear weapons, then dismantled them before joining the Nuclear Non-Proliferation Treaty in 1991. That confession proved South Africa had possessed the capability. It did not prove that one of its devices created Event 747. Additional documents exposed deeper Israeli-South African military contacts. New studies also re-examined the optical pattern, radionuclide reports, and hydroacoustic data. Some concluded that a nuclear explosion was the strongest interpretation, but decades of analysis could not recover what the original search failed to capture: uncontaminated fallout, an indisputable seismic event, or physical debris from a weapon. The Vela incident survives because there is abundant suggestive evidence, but no single piece the world is forced to accept. If Event 747 was a nuclear test, its suspected yield was only a few kilotons. It may have been a technical experiment rather than a public demonstration. A compact weapon, a specialized design, or final proof that a device worked. The storm would only need to blur one brief flash. If Israel and South Africa were involved, neither state needed to announce success. The real audience may have been only a handful of officials waiting for confirmation through a secure channel. But that remains a reconstruction, not an established fact. No responsible history of the incident can erase that boundary. The alternative is almost as unsettling. If the Ruina Panel was correct, the world's nuclear warning system produced its most convincing false alarm at precisely the moment and location where a secret test seemed politically plausible. An aging satellite, a micrometeoroid, and sunlight created a signal that divided intelligence agencies, disturbed the White House, and generated 4 decades of suspicion. Either answer exposes a weakness in the system. If it was a bomb, a nation may have violated the nuclear order and escaped official accountability because acknowledging the truth was too costly. If it was not a bomb, then sophisticated sensors and experienced analysts came dangerously close to converting an accident in orbit into a geopolitical crisis. The ocean kept no accessible crater. The atmosphere dispersed whatever traces may have existed. Governments released documents slowly, often with missing passages and unresolved contradictions. The principal witnesses aged, retired, and died. Event 747 became trapped between official uncertainty and historical probability. Today, many researchers believe the evidence favors a nuclear test. The U.S. government has never issued a definitive public attribution. South Africa denied responsibility. Israel preserved its silence. And the Ruina Panel's conclusion remains in the official record, beside intelligence assessments pointing in the opposite direction. So what flashed twice above the Southern Ocean on September 22, 1979? Was it an extraordinary accident of light and debris, or a nuclear test the world found too dangerous to acknowledge? Tell us where you stand in the comments. If you want more declassified conflicts, hidden alliances, and Cold War decisions that still shape the present, subscribe to the Modern Ledger and continue to the next investigation. Governments redact their files. History loses its weaknesses, but the Ledger remembers.